Okay, so for number 6, you actually have to use your solubility chart. And that is under the resources tab of your OneNote, and it is the reference sheet. So there you will find this chart. So let me turn up that brightness actually so you can really see it. Okay, so they're asking you about insoluble in water. Insoluble meaning it does not dissolve in water. So this chart is solubility in water. So the ones that are listed here are soluble in water, except when this. And then the ones listed down here are insoluble in water, except when this stuff happens. So we have to go through each one of these answers and try to find them in here. So NaCO3. I know that I can find CO3 right here under insoluble compounds. I want to make sure that CO3 is actually insoluble when it is with sodium. The only exceptions when it is not soluble is when it is with an NH4 plus and the alkali metals cations. So because this is CO3 and it is under the insoluble compounds, I'm going to assume that it's insoluble, but I need to check the exceptions. And the exceptions are, it will be soluble when it is next to NH4 plus, let me make that bigger, NH4 plus and the alkali metal cations. Sodium is an alkali metal cation. It is the first group, group 1. Therefore, it is an exception here. So CO3 is made soluble because of this alkali metal exception. So this one is soluble. Soluble. AgNO3. So let's look. I know that I can find NO3 here somewhere. Oh, there it is, NO3. NO3 is soluble in water except when none. It is always soluble no matter what it's with. So NO3 is soluble. MgCl2. I know that I can find Cl here, and Cl is soluble except when compounds of Ag, Pb, and Hg. Mg, magnesium, is not any of these. So this is still soluble because the only exceptions are Ag, Pb, and Hg. This is soluble. I know I can find OH in here. OH is all at the bottom right over here. OH is always insoluble except when put with compounds of NH4 plus, calcium, strontium, and barium. It is not saying anything about iron. So because iron is not an exception, OH compound, this one, is insoluble. So FeOH is insoluble. So my answer is D. That is my only insoluble one. This chart will tell you all about your anions. If you notice, all of these are, well, except this one, but all of these are going to be negative. So if it's negative, you're always going to look at your second set of stuff to find it on the chart. All right, moving on to number 7. Arrange the following particles in order of increasing mass. So we want lightest to heaviest. I know that a neutron has an atomic mass of 1, or a mass number of 1. An alpha particle looks like this with mass number 4. A beta particle looks like this with mass number 0. So I have a mass number 1, 4, and 0. If I want to put them in number of increasing mass, I have to put the lightest one first. So beta is first. And then after 0 comes 1, so my neutron is next. And after that comes my alpha, which is 4, my largest. And that is it. So this is very memory based, and this will show up on your exam. Next one, write what each symbol means in an equation. When a G is in parentheses, it means gas. It refers to a state of matter. L stands for liquid. AQ stands for aqueous. And the arrow is to produce or to form or makes. Just that something is reacting and happening. Something is happening. All right, next one. Balance the following equation. So I have titanium, carbon, and chlorine on my reactant side. I have titanium, carbon, and chlorine on my product side. On my reactant side, I have 1 atom of titanium, 1 atom of carbon, and I have 2 times 2 is 4 atoms of chlorine. On this side, I have, wait, no, this is not supposed to be there. That's a typo. I will fix it in your handout. You won't even notice that. Boom, pretend that didn't happen. You have 2 chlorine atoms. On this side, you are going to have 1 titanium atom, 3 chlorine atoms, and 1 carbon atom. So now my titaniums are are similar, are equal. My carbons are equal, and the only thing that is not is the chlorines. So I can go in and balance my equation since it is not balanced. So I can multiply this one by 2 and this one by 3 so that they both equal 6. When I do that, I have to put a 2 coefficient in front of my chlorine here. So I have to put a 2 in here. Because I did that, this coefficient also multiplies into my titanium. So my titanium is also multiplied by 2. Now I go to this side. I multiplied this side by 3, so I have to put a 3 in front of my titanium to equal, oh wait, that's chlorine. Whoops. Hold on, guys. Let me restart this. All right, I put it together. So I multiplied this side by 3 so that my chlorines would equal 6. But to do that, I need to put a 3 in front of my chlorine so that it's balanced. Cool. So now I have my chlorines balanced, my carbons are balanced, but my titaniums are not because I have 2 on this side and 1 on this side. But that's very easily fixable because I can just multiply this side by 2 to equal 2 and they match. That means I have to put this 2 coefficient in front of my titanium. So that is my balanced equation. 2, 1, 3, 2, 1. Those are the coefficients. When there's no number in front of it, it means 1. All right, next one. What type of nuclear reaction causes splitting? Anytime that I see the word splitting, I'm going to think of division. And you know what is division? Fission is division. Fission is division. Splitting is division. Fission is division. So my answer is fission. You will see this on the exam. Way more complicated, but all you have to know is that the nucleus splitting or a nucleus division is fission. That's it. All right, what are the 7 diatomic molecules? This one is just a memory thing. They are hydrogen, oxygen, nitrogen, fluorine, chlorine, iodine or iodine, and bromide. Those are the 7. 1, 2, 3, 4, 5, 6, 7. All right, next one. I have to balance out these equations. There's a lot of stuff going up in here. That is because these things in this parentheses are polyatomic ions. So what you're going to do anytime that you see polyatomic ions, you're going to just replace the whole thing with a shape or some letter instead of just worrying about each element. So I'm going to say that my blue is going to be a little blue little circle, and that my orange is going to be a little orange circle. So on my reactant side, I have aluminum, I have barium, and I have a blue little circle, right? Oh wait, I have a blue little circle, and I have an orange little circle. I have the same things on my product side, so I have aluminum, I have barium, I have blue circle, and I have an orange circle. So now I need to count how many of each I have. So I have no numbers next to aluminum. That means that I have one aluminum atom. I have no numbers next to barium. That means I have one barium atom. I have a 3 next to my blue circle stuff. So that means I have 3 blue circle stuffs. And I have no numbers next to my orange stuff. So I have 1 orange stuff. On my product side, I have 2 aluminum atoms, 1 barium because there's no number next to it, 2 blue stuff, and 3 orange stuff. So now I have to go in and try to balance these numbers out so that the equal products and reactants are the same, so that they're all equal. So let's see. I'm going to start with, let's start with orange. You can just pick random one. Remember, balancing equations is all about just randomly picking numbers until something works. So I have 3 right here. Let's multiply this side by 3 so that my 3's match. To do that, I had to put a 3 coefficient in front of my orange, which is right here. All right, so because I did that, this 3 is also multiplying my barium by 3. So now I have 3 bariums, but on this side I only have 1. So I have to multiply this one by 3. That means I have to put this 3 coefficient in front of my barium, which is right up here. And because this 3 is also in front of this blue stuff, I have to multiply the coefficient by the subscript. So 3 times 2 is 6. Where is it? Right here. Again, because I had 2 as a subscript, 3 coefficient, the coefficient multiplies the subscript, so now I have 6. So now that my bariums are equal, my orange is equal, my blue is unequal. So I can multiply this side by 2 to make it equal to 6. But that means I have to put a 2 coefficient in front of all of my blue stuff, which is right here. So because I put this 2 coefficient, I also have to multiply it into the aluminum. So now 2 times 1 is 2. And now I can see that I have 2 aluminums on both sides, 3 bariums on both sides, 6 blue stuff on both sides, and 3 orange stuff on both sides. And these are my balanced coefficients. So 2, 3, 1, if there's nothing, that means 1, and 3.